The next document that you're going to need to finish your homework is the page 142, 143, Solving Systems of Linear Equations with Graphing. This is a scan, using the Scanner Pro app, of your homework. I'm going to show you guys number 42, 43, and 46. So why don't you pause the video, make sure you have this document, and zoom it so that you can look at what the original graphs were for each one of these problems, because I'm just going to be working on the homework, and assume that you are looking at this. All right, so I suggest that you work from white paper on this so that you can really have an accurate picture of each one of the graphs and you don't have any lines in your way. So the first thing you want to do is make sure that your calculator is set up. I actually have the first one in here, but what you would do is you would actually go into your calculator, you would make sure that your plot 1 is off, you would make sure that your window is the standard. You can get there by saying zoom 6 standard, okay? And then you can go back and you can clear out any equations that you have in white equals. Everything's set up. You're good. All right, let's get to it. So in your homework, you're going to have to graph two linear systems using your graphing calculator, and therefore if any of the equations are in standard form, you're going to have to put them into slope-intercept form. So for number 42, if you look at the equations in your book from that image, from that scan, you'll notice that this does not look like the same equations, but they are. I've just put them into slope-intercept form. So that's your first step. Put your equations in slope-intercept form. The reason why you need to do that is because you can only graph slope-intercept form equations from your calculator. Next, put in each of the equations into a y1 and then your second one into y2. Make sure that you use the negative sign for negative numbers. If you accidentally use the minus sign, then you're going to get an error. So I'm just putting these in, and it doesn't really matter if you use fractions or decimals for these coefficients. I would suggest that you use fractions because sometimes the coefficients are not going to be finite decimals. They're going to be decimals that go on forever, and so you're not going to get accurate results if you have to estimate your coefficients or constants in your graph. All right, so once you have your two graphs, make sure that your two lines are highlighted, or your two equal signs are highlighted. And now we're ready to graph. Now you can see that the intersection of these two graphs is nicely put in the middle of that window. So this is going to be a really good window for this graph. Next, I'm going to just copy this graph as best as I can. No increments, no nothing. It's just a really good estimate sketch. And I'm going to put in a space so that I can put in my intersection there, the solution. Now I'm going to use my calculator to find that intersection. So I'm going to go to second trace, which will give me the calculate menu for all of the graphs. I'm going to go down to intersect. I'm going to say, okay, that's my first equation, that's my first curve. So yeah, I want that. Second curve, yes, I want the second curve. And then I'm going to yes, I want the calculator to guess my intersection. So now my intersection is 1, 3. So this means that the input of 1 produces an output of 3 for both equations. Let's go on to the next one. Now for this next equation, let's clear out these. They were already in slope-intercept form, so I can just leave them. 1 divided by 2x minus 5. 1 divided by 2x plus 3. Graph it. And here you can see there are no intersections. Just believe that there are no intersections, it's parallel. The other way that you know that it's parallel, you don't have to just take it by blind faith, is that you have the same slope but different y-intercepts. So these two lines are going to be parallel. Let's go ahead and graph these as best as we can. And so since there's no intersections, that this system has no solutions. Let's go on to 46. Oh, sorry. You didn't see that final graph there. All right, for 46, now notice that when I put number 46 into slope-intercept form, both of them, or the first one, we got the same line. So you guys are probably going to guess that this is going to have infinitely many solutions. But let's go ahead and show what it looks like on the graph. We just really want to get our minds wrapped around the concept of what it looks like, what the equations look like in slope-intercept form, and what the equations look like on our graphs. So again, using the negative for -6, so -6x minus 1, and then the other equation, I know, it's a little overkill, but hey, I want to prove this to you guys, okay? So we have the same equation, and guess what? It's only going to graph one line. Oh my goodness. Yeah, you guys probably weren't that shocked, okay? So now we have one line, and the answer, or the solutions, we call the solution infinitely many solutions. So there you have it. 3 examples for your homework.